Hello everyone, welcome back to my channel. Today we're going to cover like uh, many topics, but most of our topics is going to be actually theory. And yeah, I think this is the one. Yeah, so we're going to talk about those concepts, okay, and we will do maybe in the next video, or maybe in this video, like one or two, like maximum three labs. Like for CloudFront, we'll do one lab, and for Athena, we'll try one thing. Kinesis, we'll try also. Yes, WAF, we'll try this one as well. But most of the concepts, we'll just try to cover the theory, because yeah, that's actually the requirement for the exam as well. And even in the real world, you're going to use this stuff, but most of the setup is very straightforward. Okay, and you required, if you understand the concept, then you will be able to implement it practically easily, by checking the docs or checking online. So let's just go ahead with the first topic, which is Amazon Elastic Cache. Okay, so what is Amazon Elastic Cache? It's a database. When the databases are slow, we know that, right? Database is slow. Okay, because the reason they are slow is because they are stored in the disk. They're disk based, right? Input output bottleneck is the main issue why databases are slow, and they have expensive queries also, like joins and aggregation. Yeah. The thing is, Elastic Cache, it moves the data to the RAM, which makes it faster. Okay, microsecond latency. That's the benefit of Elastic Cache. Okay, moves the data to the RAM. Okay, so and yeah, so this is what we have. Okay, this is the difference, and there are two types of caching mechanisms. Actually, we have Redis and we have memcached. Redis, we've talked about it in our full stack career development course that we had before this course. Like, we've talked about it in detail. This is just it's used for caching. Basically, it's the most common, most used caching tool, Redis. Okay, so yeah, it provides persistence. Memcache is one more, okay, tool that but doesn't provide persistence. Okay, but Redis does provide persistence. This is the difference between Memcache and Redis. And the data type that Redis allow, we can have strings, lists, sets, whatever. Memcache, it has to be key value only. Okay, and Redis and has is good for scaling. Scaling is complex. Sorry, scaling is complex, but Memcache is simple. Okay, and the Redis use case, we can use Redis for sessions, queues, leaderboards, and Memcache for simple caching. Basically, we will use Redis for most use cases, but Memcache we use it only for simple use cases. Okay, so if you see, like, for example, when you need the persistence in exam, for example, it will ask you like which caching mechanism, tool, or library provides persistence, Redis or Memcache, right? And persistence and complex logic, Redis, obviously. And would provide simple cache, then Memcached. Okay, and common mistake, we have cache is not source of truth, always fall back to database. Yeah, yeah. So one more thing, next is connection management. Okay, when we say connection management, okay, actually I don't, we can Elastic Cache. Well, 1 second, let me just see what we can see. Elastic Cache here. 1 second. it's just caching actually. Yeah, or keep it. Let us finish our course deeply, and we'll just have a look at each one briefly. Yeah. So connection management. Okay, this is we use AWS has something, a service called Amazon RDS proxy. This is used for connection management. Okay, the real problem is database cannot handle thousands of connections. Okay, and especially AWS Lambda scales instantly, creates many connections. Okay, so what RDS proxy does, it provides connection polling, reuses connection, reduces database memory, CPU usage. Okay, so connection management, it provides connection pooling. Also, we talked about in our full stack development course. Okay, connection management. So a database cannot handle thousands of connections. So what it does, it creates like multiple connections, it keeps it open. So in case there are more, if there are additional connections, they can reuse the existing connections. That's the idea of connection pooling, basically. That's the benefit of Amazon RDS proxy. Okay, so for the exams, they may ask like intermittent database failure under load. That means we can use RDS proxy. Lambda plus RDS scaling issue, then we can use RDS proxy. Just remember these two concepts. Okay, the purpose of RDS proxy just creates many, like it creates like 4 or 5 connections. Okay, keeps it open, and whenever there are additional connections, it will reuse the existing connections. Okay, so the idea is to reuse connections, to allow the database to reuse existing connections. Okay, so to reduce memory and CPU usage, basically. Containers. When we talk about containers, we have Amazon ECS and AWS Fargate. Okay, so containers equals to packaged app plus dependency that runs anywhere. Okay, so we know about containers. Containers is just a way to like run your application. If you want to run your application, okay, for example, if you want to run Postgres database, SQL database, okay, you can use Docker container and run your Postgres SQL inside the container. Okay, this container you can run it anywhere. It's yeah, it can be used anywhere, can be run anywhere, and it's simple to set up. That's the idea of container. It simplifies this process. Okay, and the difference between ECS and EC2, okay, ECS EC2 versus Fargate, okay, is that ECS EC2 has full control. You have full control. Fargate limited. So the thing is, this is how it works basically. Let me just show you in a diagram so we can actually understand how it works. Let me remove this one. Okay, so when we talk about ECS and Fargate, we have let's say we'll have this 1, 2, and 3. Okay, okay, this one I'm going to put it here. Yeah, this is one second, I'm going to add this one here. EC2 instance 1. Okay, and I'm just going to copy this one and paste it here. EC2 instance 2. Okay, and paste it here. EC2 instance 3. Okay, so you have 3 instances, right? You'll have to create 3 instances, 2 or 3, whatever any instance you have, how much you need, and then you're going to install inside it Inside it, you will install your containers, Docker containers or whatever containers. Okay, inside this, you will install containers. You will install the containers inside it. Okay, let me just increase the size here, and inside the EC2 instances, basically. That's the idea of this, actually. You'll have star. طيب. Okay, so this is the purpose. You'll create three. You're responsible. This is this one that I'm showing you now is actually ECS EC2. Okay, ECS EC2 one. Okay, this way. If you create your containers this way, so you will create first of all EC2 instances. Inside it, you'll create the containers, then you will put it inside a cluster. No, let me just cut this one, and let's create here one. This three will be inside the same yeah, so ECS cluster. Okay, so this is your ECS cluster. Okay, so this is the idea of ECS EC2. Okay, so ECS, okay, it's going to handle this provision your containers. Okay, like if there's a container down, or you want to you want, if there is an issue with the container or stopped, or you want to create additional container, ECS is going to simplify this process. It's going to manage it for you. Okay, but there is one issue with this setup. The EC2 instance, you're responsible for it. You're responsible for the instance, for provisioning the instances, for managing the instances. Okay, ECS is only going to handle the containers. That's it. Containers inside this EC2 instances. Okay, like but it's not going to manage your EC2 instances. You're going to manage this one. That's the difference. However, if we use Fargate, okay, you see this one, even ECS EC2 here, it's scaling is mentioned manual, right? Yeah, you have to manually create if you want to scale. If you want to add more containers or something like that on different EC2 instances, you have to manually create additional provision additional EC2 instances here again and again, and manually do it, because and cost is cheaper to at scale management. You manage the servers. You see, this is the thing with the EC2 ECS. But however, there is a new way to do this using Fargate. Fargate gives you limited control. Okay, yeah, remember ECS here you had full control. You had control on the EC2 instance, and you had the control on the container, everything. But here Fargate it's limited, but scaling is automatic. It will handle all this stuff. Okay, and it's serverless, basically serverless. Okay, and the cost is pay per use. Okay, you will only pay for what you use. That's it. This Fargate management, AWS manages everything. You don't manage any server, you don't manage anything. Okay, AWS handles all this manual stuff that we just showed you here. You don't need to provision EC2 instance, you don't need to do anything. So this is how Fargate simplifies everything for you. So the decision, when you make a decision, if you want control and cheaper long term, choose the EC2 ECS instance. But if you want simplicity and no operation, just choose Fargate. So that's the idea. Fargate is not always cheaper. Yeah, that's it. So this point is clear actually. So let's move on to the third one, which is the database design. Okay, the database design, which we have at Amazon RDS. Amazon RDS, okay, is basically, yeah, until now we talked about DynamoDB, right? Database, okay? That one was for NoSQL databases, okay? Amazon RDS is for relational databases, okay? Relational databases. It's a service in AWS that's used to create a relational database, okay? So it has two key features, okay? When you create Amazon RDS, it's going to give you two features. It has multiple AZ, multiple availability zone features. You can create relational database with multiple availability zones, which allows synchronous replications and standby instances and automatic failover. Okay, the purpose is availability, not performance. The purpose is availability, not performance. Okay, multiple AZ means multiple availability zones. That means you will have a database in multiple availability zones. Okay, so you will have replications, you will have standby instances, like, yeah, you will have instances like in case one database is down, the other one will take over or something like that, automatic failover stuff. That's multiple AZ. Okay, read replica, however, is asynchronous replication. Read replica is like you will have multiple replicas possible. That means you will have databases that are designed only for reads. Reads mean like, for example, just to fetch data from it. Okay, for example, let me give you an example. Like, let's say you have an application that's read heavy. That means people are mostly just going to see. They're going to see the contents or posts or whatever. Okay, they're not going to. They will need to see like Instagram or Twitter, whatever. Those applications, I think they are considered read heavy because usually you're just going to swipe and see the data more than you are going to post or write or edit, right? So the idea is the read replica, having multiple replicas, okay, so that it can reduce the load on a single database. So if you have a if database crashes and you need a backup, use multi-AZ. This is for failover. If you have too many read queries, okay, it's like use read replicas. That's the difference. If you need both, use both. Okay, and we have here CDN. Okay, CDN is one more topic. We are going to talk about CDN. 1 second. Okay. So yeah, that's the idea of the Amazon RDS, basically, the relational database. So you just need to know the difference between these two. Okay, if you have too many read queries, then you have to use read replica. If you need just a backup, you don't need anything like read queries and something. You have to use multiple AZ. Okay, and we have here one more CDN. CDN is basically an Amazon CloudFront. Okay. The deep concept is the idea is without CDN, user or server far away equals to slow. Yeah, basically with CDN, nearest edge cached fast. So the idea of CloudFront is that CDN or CloudFront is Amazon CloudFront is a service in Amazon that provides CDN. Okay, but the idea of CDN is like let me show you here. Let me just remove this one. Let me remove this one. Okay, assume that you are here right now. Okay, and you want to access a server here in this is, let's say, India, for example. India, for example. And the server here we have in the USA. Okay, so basically when you want to access a system or a website or anything that is hosted inside the servers on the US, okay, so you will have to go through, every time you will have to go to the US to retrieve the data, okay, or to update or whatever. Yeah, you want to interact with the system or website, you have to go to the US, right? And there is a distance here. There is a long distance between India and the USA, right? So this will cause latency, and this will make it also slow, right? So there is a solution for this, and we call it CDN. CDN, you put this is a CDN, for example. Okay, this is inside let's say your country. Okay, so what it does is basically it's just going to cache the data it receives from here. It's going to put it here, cache it. Okay, next time you need to get something, you just get from the cache. You don't need to go directly to USA, right? So basically that's the idea of CDN. CDN. Okay, this edge server and nearest to your location, okay, or country, and it's used to, it will cache the data for you, okay, and you can retrieve it whenever you need it to retrieve. Okay, so you don't have to go again and again to the USA. That's the benefit of CDN. Okay, user server far away, it's slow, and with CDN the nearest edge cached fast. That's the concept of CloudFront. That's CDN. Amazon CloudFront and TTL. This how long cache lives. Okay, that's the idea of TTL. How long a cache lives. When we talk about TTL, it's time to live. Okay, like when you put TTL, that means if you put 200. So, like how long if the cache will stay in the cache. Basically, the data will stay in the cache. So, and the other thing is cache hit versus cache miss. The difference is cache hit means that we found the data inside the cache, stored in the cache. So we don't need to go to the database, right? If it's a miss, that means it's not available in the cache, so we have to go to the database. Origin fallback, basically. Origin means to the main database. Okay, that's the idea. So advanced traps, dynamic content, less caching. Yeah, dynamic content, because if a content is always changing, you cannot use caching, right? You cannot cache the data because it has to be you have to reduce the caching, right? Because you need to get the latest updated data. Okay, if private S3, use OIC. If validation costs money, yeah, if validation is expensive. If validation is just removing the old caches, okay, when there are changes made, like cache and validate, yeah, it costs money. So we want to try this lab actually, but we'll do it later. We'll keep the lab at the end. Again, important for us is to understand the concept. It's not the labs actually. For this sets of things, we just have to understand the concept. Like we have to understand, for example, what is Amazon? What's the purpose of this service, Amazon CloudFront? So we know that it's used for CDN, right? And what's the purpose of Amazon RDS service in AWS? We know that it's just provides relation and database services. It has two features like multi-AZ and read replica. We know what to choose and when to choose each. Yeah, that's the concept, right? Same goes with AWS, Amazon ECS, Fargate, RDS proxy. All this, you just have to understand like the differences and the benefits, the purpose, like just the key concepts. Okay, so let's go to AWS Global Accelerator. Okay, the deep difference versus CloudFront. So CloudFront uses HTTP, right? It provides caching, and it's used for static and dynamic content. Right? So Global Accelerator uses TCP UDP. Okay, and it uses its method is routing, and its use case is for gaming and API. Basically, that's the difference between CloudFront and Global Accelerator. It improves API latency globally without caching. This is the purpose of Global Accelerator. So if they ask us what's purpose of Global Accelerator, it's used for network optimization. It uses TCP UDP, it doesn't use HTTP. This is a completely different concept. And its common use case is for API latency. Improves API latency globally without caching. This is the concept that we need to remember. And yeah, and we have here security layer, AWS WAF plus AWS Shield. And WAF is like web application firewall. Actually, it inspects HTTP requests, rule-based filtering, think like smart filtering. So it's just a firewall. Okay, AWS WAF is just a firewall used for web applications. Okay, it sits in application layer 7. This is the application layer, right? It inspects the HTTP requests, whatever HTTP request we make, checks it, and it has a rule-based filtering. Okay, like think of it like smart filter basically. This is WAF. And Shield, AWS Shield, it is a network layer, not an application layer. It goes in the network layer, layer 3 and 4. It protects against DDoS attacks, for example, and think traffic flood protection. That's the difference. Okay, the difference between WAF and Shield is WAF is just application layer. Shield is protects us from DDoS attacks. Okay, it's traffic flood protection. So yeah, it's recommended to use both actually. And this is it, combined usage. Okay, and we have streaming. Okay, Amazon Kinesis. Okay, we have streams versus Firehose. So yeah, so just so we can review this one, we said that in AWS Global Accelerator, what it does, it just improves the API latency mostly. Okay, this is its most use case, like without caching, basically. Okay, it uses TCP UDP here, right? It's used for routing. It's used for routing. Yeah, it's used for routing. And yeah, here we said the difference between AWS WAF and AWS Shield. We said that AWS WAF works on application layer. It inspects HTTP traffic, filters. It has rule-based filtering. AWS Shield, it's used for to protect. It works in network layer. It protects against DDoS attack. So. Okay, so there are a few things that we need to understand here, these three, and we want to understand it together. Okay, we have, for example, Amazon Kinesis Firehose. This is the main one. This data streaming service. Okay, basically, imagine you have a data being generated continuously, like real-time logs from your website, for example. Okay, say you have logs from your website coming from your website, or it's coming from data that's coming from sensor data of IoT devices or social media posts. Okay, you need a way to collect, store, process this data in real time, right? So How can you do that? You use Amazon Kinesis Firehose. It's a service that helps you do exactly that. It allows you to easily stream real-time data into storage services like Amazon S3 or Amazon Redshift or even other tools if for analytics. That's the idea of Amazon Kinesis. This is the key thing that we need to understand about Amazon Kinesis Firehose. Okay, it allows you to easily stream real-time data into like Amazon S3 or Redshift, right? So once now that and now that you have all the raw data in Amazon S3. Okay, let's say we put all the raw data inside Amazon S3 from using Kinesis Firehose, right? From our, like, let's say it's a log from our website. Okay, we put it all inside Amazon S3. We put it using Amazon Firehose Kinesis. Then once we got this raw data in S3, okay, you might want to analyze or query it, right? Like you don't want to move the data around. You want to work with it where it is. Okay, so we can use Athena for this. It's a service that allows you to query. Yeah, this is important. It's a service that allows you to query data directly from S3 using SQL. You know SQL, right? It's like you would a regular database. That's it. That's the purpose of basically Athena. Okay. Now that we have all our data inside S3, we use Athena to query it. It's serverless, which means you don't need to set up servers to run queries. You just write SQL queries to analyze the data as it sits in S3. You only pay for what queries you run based on how much data is cleaned. That's it. Okay, so AWS Glue or data transformation or ETL. AWS Glue is actually in real life scenario, raw data isn't always in the right shape for analysis, right? You might need to clean it, organize it, or transform it. This is the purpose of AWS Glue. That's it. Okay, it just takes the raw data and clean it, and organize it and transform it to more useful format. So AWS Glue is the service that helps that process. It's like Data Chef takes the raw ingredients, turns it into and these are extra details, like you can extract data from different sources, transform it to useful, and load it to target system. So until now, up to here, we understood. Yeah, and let's go to the last part, which is Amazon Redshift. This is data warehousing. Once your data is cleaned up and ready for analysis, you might want to store it in a way that makes running complex queries faster and more efficient. Okay, Amazon Redshift is a data warehouse that allows you to do this. Think of it like a giant database optimized for running fast analytic queries on large dataset. It stores structured data and data organized in tables and columns like regular database. Allows you to run a SQL query at lightning speed. This is speed. Okay, see, if you notice the definition between the definition when we defined Amazon Redshift and Athena, like it has some similar features, right? But the thing is, this is faster. This is allows you to run SQL queries at lightning speed. This is Amazon Redshift allows you to run complex queries faster and more efficient. Okay, but Athena allows you to query data directly from S3 using SQL. This is like a regular. This is normal. Okay, this is faster. So how they all work together? Kinesis Firehose streams data in real time to Amazon S3. Yeah, this is what we said. It's the first step. And Amazon Glue, it might clean it, transform it, prepare the data before moving it to more structured format. Okay, so you store clean data in Amazon Redshift for easy and fast querying. Okay, and when you need to run queries, you can use Amazon Athena to analyze raw data directly without moving it anywhere. This is also different. In summary, Kinesis, yeah. Yeah, so yeah, Redshift lets you store and analyze it efficiently in data warehousing. So these are the key concepts that we need to remember, and that's it. Let's go ahead and continue. Now that we know the key differences here. AWS Database Migration Service, okay, it's provides continuous replication, okay, minimal downtime, migrates with zero downtime. So that's the job of database migration service. I think this is very straightforward. It just helps you migrate your database from one location to another. Migrates with zero downtime, basically. That's the idea. And the monitoring stack, we have we know about CloudWatch, we've talked about it before. So the idea is it provides metrics, like it's just for like CPU numbers and logs, text, alarms, triggers. CloudWatch is not like auditing, just gives you logs, basically, like monitoring logs and stuff like that. And AWS CloudTrail tracks API calls. This is the difference. See, CloudTrail is used to monitor API calls, okay? Like, for example, who deleted EC2 instance? You can find it in CloudTrail. If I delete an EC2 instance, I can find it in CloudTrail, okay? Remember, AWS CloudTrail tracks API calls. AWS config dprol tracks configuration over time, okay? Was S3 ever public? Config. You can find it on config. Tracks configuration change over time. That's the idea of AWS config. So we just have to skim these points, and I don't think we need to go deep through each, but let's go ahead. What's Amazon Neptune? It's a relationships social network. Document DB, flexible JSON data. Yeah, it's just document DB, flexible JSON data. Amazon key space, massive scale, no SQL. And security, we have Cloud HSM, which gives you full control of keys. Audit Manager automates audits, basically. AWS Artifacts, it provides compliance documents. Amazon Macy, it detects PIE, like yeah. Amazon Detective investigates incidents. AWS Control Tower manages accounts. Amazon Open Search Service logs and searches. AWS Application Migration Service moves up application. So the full these are just concepts. Just understand why they exist. You don't need to go deep to each one because they're not really that much important, but you can see it. So the final mental model, what we need to know is, like, if we need performance, obviously we will use Elastic Cache and CloudFront, like for CDN and caching. You need compute, we use ECS and Fargate and Lambda. This is for that one. For containers, right? To manage container, provision containers. Database, we use this one, S3. So this is it. So we have so Athena, what we have here, like yeah, imagine basically we're repeating here. Imagine your website lives in server in US, user in Japan visits it, the data has to travel across entire Pacific Ocean. That's slow. CloudFront fixes it. It's a CDN. It copies your content to over 400 plus edge locations around the world. When someone requests your content, it serves it from the nearest location, not from your original server far away, right? Origin, where you where your real content lives. Basically, this is the origin. S3 bucket, an API, load balancer. Edge location, the cache copy closest to the user. TTE, how long the cache keeps content before refreshing from the origin. Let's go to security. Security settings to ensure only this is origin access control, means OSE. Security settings to ensure only CloudFront can access your private S3 bucket, not the public internet. Okay, improve global performance or serve content faster. We can use CloudFront. Yeah. So Amazon Athena, we query, we said that Amazon Athena is used to query S3 with SQL. Normally to query data you need a database, right? You load data and set up managed service. There's a lot of overhead. Okay. Set up table, manage servers. Yeah. So Athena skips all that. You point it at files sitting in S3 like CSV or JSON or Parquet, and you can just write normal SQL queries and get results back. No database to manage, no server to run. You only pay per query. That's the purpose of Athena. File sits in S3. Athena reads them on demand using SQL. The result appears in seconds and minutes. Okay. AWS Glue is often paired with the Athena. Glue scans your S3 files, auto creates data catalogs, structure, so Athena knows which column exists. So basically Athena. Kinesis Firehose, we said this is used for real-time data pipeline. Imagine your app is generating thousands of events per second, clicks, logs, sensor readings. You need to collect all of that, store it somewhere like S3 or Shifter. It's a fully managed pipeline, just streaming data, delivers it to destination automatically. You don't have to manage any servers. Firehose, simply fully managed, just delivery, no custom processing needed. Data stream, more control, you write the code. Okay, collects, loaded to S3 or Redshift. That's Firehose basically. And last, WAF. WAF sits in the front of your web application, inspects every incoming HTTP request. It can allow or block requests based on rules you define. What it blocks? SQL injection, attackers trying to manipulate your database through form field, accesses, injecting malicious scripts in your page. It blocks bad IP addresses, blocks known attacker IP or whole countries. Rate limiting, blocks single IP sending too many requests. So this is the benefits of WAF. Actually protects you from all this. The WAF can integrate with CloudFront, application load balancing, API gateways. So now we finished everything, so let's go ahead and do the demo. So let's create an S3 bucket. Okay, upload an index.html file, just a simple HTML page. Okay, and then we will keep the bucket private. Okay, block all public access. Okay, and then go to CloudFront. Okay, then we will create a redistribution. Okay, and we will set origin domain like our S3 bucket obviously, and then under origin access we'll select origin access control. We will create a new origin access control. Okay, and AWS will ask you to update the S3 bucket policy. Copy and paste the policy it gives you to S3 bucket permission. Okay, and then you can create redistribution. Wait 5 minutes for deployment. Copy CloudFront domain. When it's in your browser, it will try its different location using VPN. Notice S3 is private, but only CloudFront can serve a file. User everywhere gets it fast from the nearest edge. So the idea is of this demo. Okay, so this demo, what we are doing basically, we're just creating an S3 bucket. Okay, we're going to keep it private. Okay, it's not public. Okay, you won't be able to access it. You're not going to be able to access it. from the internet. However, you can use CloudFront, okay, to allow it to go inside. Use CloudFront to link it with S3 and give it the necessary policy or permission to CloudFront, and then you will be able to access the S3. So faster يعني. Amazon Athena, basically we will just create an S3 bucket, upload CSV flyer like this one for example, like ID, name, city, whatever, and we'll create a second S3 bucket for Athena results. Athena needs somewhere to save output. Replace crawler, create crawler, point it to S3, create a new database, run this one, query editor, set output location to the second bucket, and that's it. Basically we're going to try this one. We're going to try to do this labs, actually this 4 labs, and I will do this labs on the next session. Okay, just will focus only on those labs, on those 4 labs on the next session. Okay, but we've completed the theory. Now we understand what each does. Okay, we're going to focus on the lab, on how we can set up these labs on the next session. Thank you for watching and see you on the next session.